Hello! Welcome to Lecture 4, Quiz Explanation. Once again, you are joined with me and Panda from Lecture 3. Remember? Hello! Okay, so without further ado, let's just dive straight into the questions, right? So let's begin with question 1. Which of the following statements are true about the do-while loop? One option that many students chose is the do-while loop will repeat the actions inside it until it has met the terminating condition. Now, you are not wrong when you say that the do-while and do-until loop are the opposite of each other. That is true, right? The do-until loop, right? We have to specify specifically when to stop. Alright, the do-while loop, we specify very specifically when to keep looping. Now, that is a when to keep looping condition, the condition for when to keep continuing. It is not the same as a terminating condition. The terminating condition, yes, I know we can say that it is the opposite, right? But that takes a bit of a one step in your mind to make that translation, yeah? So, I want us to be very clear about the difference. Do-while contains the condition to keep repeating. Do-until contains the condition to stop. Now, why am I making this very distinct? Because in the first place, why do we have two loops? Because in some cases, the condition to keep looping is very clear, but the condition to stop is not clear at all. Okay. In some cases, the condition to stop is very clear, but the condition to keep looping is not clear at all, right? So we use these two when the situation, depending on the situation, alright? Okay, the next option is the do-while loop will repeat the actions inside it as long as the condition to repeat continues to be true. That's exactly what I just said, right? In pseudocode, the end loop is written to indicate that everything from the do-while loop to the end loop will be repeated. Just as how end if is like close bracket, right? So end loop is sort of like the close bracket, but in this case, we can't write loops in Excel. Well, technically, you know how you do your formula on like row 2 and then you double click the square and then the formula replicates on all the rows below. That is a loop, do until the end, or for every row that has stuff, keep repeating. So in many ways we have been doing all this loop stuff, but just not typing out code for it. Alright? So anyway, end loop is not a command, right? Which brings us to the next option. End loop is not a command at all. It's just a signifier to tell you this is the end of the set of instructions for the loop. Alright? Now, why do we do this? Because without an end loop, okay, let's say I have an instruction, okay, that without an end loop, it's not clear whether this command should be inside the loop or outside the loop. So the end loop makes it very clear for you and me and Panda on when to repeat and when not to repeat. Alright? Okay, moving on. You can put a do-while loop within another do-while loop. Yes! You can put it also inside a for loop. You can also put it inside a do-until loop. Loop the loop. How many loops you like to loop until you hoop also can. Next one. You are not allowed to put a do-while loop within a do-while loop. No, not true. You are very much allowed. And so this brings us to the next question, which is you're organizing a camp for your CCA, you decide to treat them to bubble tea, and in the process of doing so, you realize everyone only likes one of 3 types of bubble tea. So, what is the right answer? Now, let's look at the algorithm for the correct answer, shall we? Do while there are unconsidered members, and then select the first unconsidered member as the current member. Now, I think it helps if I demonstrate this by illustrating to you. Alright, so let's say I have A, B, C, D. Alright, so do while there are unconsidered members. So are there? Yeah, there are. We got 4 unconsidered members, right? Select the first unconsidered member as the current member. Okay, now ask what is the desired drink, and then okay, let's say A likes milk tea with pearl. Okay, MT with pearl. Okay, so that's 1. Okay, then so we plus 1 for that. Then the next one, no, person A doesn't want milk tea without pearl, doesn't want milk tea without pearl, no sugar. Okay, after that, the next instruction is mark current member as considered. So I put a tick to say that this person is considered. Okay, now next we go back, we reach the end loop. Now we go back to the top. Do while there are unconsidered members. Alright, so we look at our list. Do we have unconsidered members? Yes, we do, right? Person B. So let's select person B as our current member. Okay, and then we go through the motion again, and then we ask, what milk tea do you want? Do you want milk tea with pearl? No. Do you want milk tea without pearl? Yes. Okay, so milk tea without pearl plus. Okay, so we plus one to our counter. Then do you want milk tea without pearl, no sugar, blah blah blah. Okay, then mark current member as considered. So we put a tick. Very good. Okay, then end loop, we go back to the top. Do we have unconsidered members? Yes, we do. Person C, right? So we mark person C as the current one. We select person C as the current one, and then we do the same. And let's say this person wants milk tea with pearl also, okay? And then again, you mark as considered. And then, do we still have unconsidered members? Yes, we do. So we select as current, and then we ask, and then this person wants milk tea without pearl. Alright, and then we mark as considered. Now we go to the end loop, and again we go back up to the do while. Are there unconsidered members? So let's have a look. No, this one's considered, this one's considered, this one's considered, this one's considered. We have no more unconsidered members. So now we terminate the loop. Okay, so what do we have? We put quantity of all the counters. So 2 milk tea with pearl, 2 milk tea without pearl. End of story. Okay, so let's see what's wrong with the other options, shall we? Okay, here we have another algorithm. Okay, let's just have 2 people just to test the algorithm. This is how we test the algorithm. Okay, for many of us who have not internalized the concepts of loops and conditionals, it's very important for us to work this out on paper until we get a better sense. Once you have a very, very good sense, then you can do all this without the paper working or anything like that, because it becomes part of your mental sums capability. Alright, now, so let's try do while there are unconsidered members. Do we have unconsidered members? Yes, we do, correct? So we select A as the current member, and then we ask for the drink, and then let's say this fellow wants milk tea with pearl. Okay, very good. Notice what's different with this algorithm. We do not mark the person as considered. Okay, so we end the loop, and then we go back to the top of the loop. Do while there are unconsidered members. Select the first unconsidered member as the current member. Who do you think we will select? Haha, we will select person A again. So you can see where this is going, right? We will keep repeating the loop. We'll keep asking person A over and over and over and over until this person quits the CCA, correct? Okay, so let's move on to our third option, shall we? Now, this one, the algorithm says do while there are no unconsidered members. Alright, so now pay attention to this. We have 2 members, they are unconsidered, right? Now, notice it is do while there are no unconsidered members. It's not do until there are no unconsidered members. So what's going to happen? We don't have no unconsidered members, right? Okay, let that sink in for a while. We do not have no unconsidered members. Therefore, the condition to keep looping is not true. Therefore, we will not execute the loop at all. Alright, so in other words, we will not ask anyone. Okay, so how about the last option? Do while there are members. Immediately, this one should strike you as something wrong, right? Do while there are members. This is a loop that will never end. This is the loop that never ends. Okay, so because we're not even considering whether they're considered or unconsidered, right? So there are members, there will always be members. Essentially, this loop ends when the entire CCA closes down, right? Okay, very good, very good. Not good for the CCA lah. I mean, very good that you understand. Okay, so let's move on to the next question. For loop. Alright. In the lecture videos, you learned about the for loop. What sets it apart from the do while loop? Okay, so the correct answer is that the for loop applies the same set of instructions to each item in a list. That is the one thing that sets it very distinctly from the do while do until loop. Because the for loop, to put it very simply, has a built-in tracker. If you notice all the sample algorithms that we're showing you for the do while do until loop, if we need to keep track of where we are in the list, we need a counter. counter, you know, like click, 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 click. Then that way we can keep track of it. The for loop has it built in. The counter is already built into the for loop so that we can keep track of our current location. Alright? Okay, so let's move on to the next question now. This question, unfortunately, I have to moderate and everybody gets a free 1 mark. Why? Because I made a very, very critical typo. I left out one phrase which changes the question altogether, and I tried to contact every student who was affected by the typo, but not everyone got back to me. So I think, okay, let's just play safe. Let's make everybody happy. You all get the 1 mark. As long as you try this question, you get the 1 mark. Alright? Yeah, okay, but just for your interest, let me explain how this algorithm works so that we have a better understanding, alright? For each line in the academic paper, read the current line. If the line contains help me, save me and my cat, then delete the entire line. And then next line, the academic paper. Now, how do we interpret that? Okay, so basically, it is a for loop. So let's say the academic paper has 5 lines, okay? So let me just visualize for you. Okay, this is line 1, this is line 2, this is line 3, this is line 4, this is line 5. Alright, for each line, so we always begin with the first line, right? Read the current line. Does it contain help me, save me and my cat? If it does, then you delete, right? So let's say this one doesn't contain. Okay, very good. Then we will just move on to the next line. Does this line contain the phrase, the line help me, save me and my cat? If it does, then we will delete this line. Okay, and then what do we do? Next line in the academic paper. So we move on to here. Does it have the line? No. Okay, very good. Then we move on to the next line. Does it have the offending phrase help me, save me and my cat? If it does, then we delete the thing. Okay, now you get the idea, right? Now, so let's look at the options and we'll see why it's right or wrong. Okay, so the question is, which of the following will you do if you follow the algorithm? Okay, you will stop reading upon reaching the first line containing help me, save me and my cat. Clearly, this is not in the algorithm, so that is wrong. You will read every single line in the academic paper, including all those lines without the words help me, save me and my cat. Right? Because the way the algorithm is written, this for loop will check from the first line to the last line. It is blind to the number of times the words help me, save me and my cat will appear. Right? Now, next option, you will stop reading immediately once you find the 5 lines with help me, save me and my cat. Again, the loop is blind to how many times this exists, so it will not automatically stop reading after it finds the 5 lines. Okay, next one, you will delete the 5 times that help me, save me and my cat appears in the academic paper, because the story tells you it appears 5 times. That's why you and I know that the loop will delete those 5 instances. Okay, so that is the correct option. Next one, you will delete the first 5 lines of the academic paper. Clearly, that is not what the algorithm is telling you to do, so that is wrong. You will stop reading the academic paper immediately after you have deleted the 5th occurrence of the words. No, nowhere in the loop does it say stop upon deleting the 5th one. Okay, I don't want to repeat myself, so you already get the point. Next option, you will stop reading the academic paper after you deleted the first 4 times the words help me, save me and my cat appears in the paper. Okay, I purposely put 4 times just to make some of you doubt, because if you understand the concept of a loop, you know that you will know how many times it will run and all that, right? So this is just to kind of like mess with you to see whether you really understand. So this is wrong, because why? Again, the loop is blind. If we know how many times it deletes, it's because we know how many times the line was inserted. Okay, next one, you will only delete the first 4 times that help me, save me and my cat appears in the academic papers. Here the option is saying, once you delete the first 4, then rather you can run the loop from start to finish, but you only delete the first 4. Again, this is not true, right? Nowhere in our algorithm does it allow us to do that. Okay, so let's move on to the next question. In an alternate Marvel universe, okay, Thor had a falling out with the rest of the Avengers, and he decides to create his own gang of superheroes, the Revengers. Okay, thus far the Revengers has only 2 people, himself and you, his super secretary. So he wants to hire more more superheroes. Yeah, okay. Okay, depending on which variant you got. One variant says interview the applicants and shortlist just one candidate. The other variant says interview the applicants and shortlist all candidates. Okay, so let's go through the options and see how we can distinguish the various options. The options are all the same across the different variants. First option says do while there are unconsidered superhero applicants. Then select the first unconsidered superhero. Okay, so again, let me just do visual representation in case it's not clear. So let's say I have superhero, I have A-Man, A-Man. Okay, then we have B-Man, B-Man, and then we have C. No, I'm not gonna say that word. Okay. Okay. Okay, that was it. Alright, anyway, so we have A-Man, B-Man, and then what I will not say on YouTube. Okay, so look at that, my full face is red. Okay, so what is this algorithm going to do? Select the first unconsidered guy, okay, and then interview. Okay, if it meets Toss criteria, then we shortlist, else we reject. Then we mark the fellow as considered. Okay, very good. Now and look, then we go back and we ask the condition. Do while there are unconsidered superhero applicants. Okay. So there are unconsidered superhero applicants, right? So I will select the first unconsidered, which is B-Man, and then what do? I will interview, and then I will mark as considered. Do I still continue? Yes, because there are still unconsidered superhero applicants, and then I will select. I will go and select the first unconsidered superhero, which is C person. And then I will interview and then mark as considered. And now my loop will come to an end, right? Notice this loop goes through every single applicant. So it is possible that I will shortlist one person, but I could potentially shortlist all of them if they qualify, correct? Now let's go on to option number 2, okay? Do while there is no shortlisted applicant, right? So as long as we haven't shortlisted anyone, keep repeating, keep looping, okay? So let me change the letters of the alphabet. We have X-Men, you know, Wolverine with the claw. Okay, anyway, so we have X-Men, Y-Man, and Z-Man, okay? So, what do? Do while there is no shortlisted applicant. Okay, very good. Then we will select the first person as the current applicant, interview, and then mark as considered. Now, okay, let's say this guy got rejected. Okay, so we X the X-Men. Okay, but we mark as considered, right? So do while there is no shortlisted applicant means we will repeat the loop and then we will look at Y-Man, right? Y-Man, let's say Thor likes Y-Man. Okay, so then we shortlist the person, right? And then we mark as considered. Now, what's going to happen? Because I already have one shortlisted applicant, do while there is no shortlisted applicant. Notice, I have one already, so the condition to repeat is now false, right? It's not true anymore. So what do? I will terminate the loop immediately upon finding the first shortlisted applicant, right? So next option is do until there is a shortlisted applicant. You already can see where this is going, right? I think some of you already starting to generate your mental sums engine in your head is starting to work already, right? We will keep looping until we get one shortlisted applicant. That is our terminating condition. So we will only pick one. This algorithm will pick one. Okay, next one. Do until there are no unconsidered applicants. I think by now you see the picture, right? You get the point, right? So this one we keep repeating until we have no more people who are unconsidered. Alright, so this can give us potentially one or more shortlisted applicants, right? Okay, next one. For each applicant on the list of applicants. This one is a for loop. For loop will go from start to finish, right? So this one will cause us to keep looping and shortlist many people. The last one is still a for loop. Okay, so we have to go from start to finish. But notice something interesting about the if conditional. If the current applicant meets Thor's criteria and the number of shortlisted applicants is 0, then you shortlist. Otherwise, even if the person meets Thor's criteria, if you already have one shortlisted applicant, what are you going to do? You will reject that fella, right? So option number 6 will give you one shortlisted candidate. Alright, next question, we have the question about the loop in the loop. Loop the loop, loop in the loop, hole in the hoop. Okay, anyway, so now, not easy to understand, and I try to make it to help you to learn by reading the entire explanation. I know it's very long, but if you notice there is a lot of repetition so that you can see the pattern, you can apply pattern recognition, see the pattern and understand what we're trying to do lah. Okay, so what do we have here? Okay, let me go straight into the algorithm. Let me just write out the inputs on the screen. Okay, so you have Alexandria, you have Belexandria, you have Calexandria, Delexandria, and then you have Alexandria. Okay, favorite number 2, 3, 2, 4, 1. Okay, favorite food, pizza, and then you have chicken, then you have ice cream, then you have chocolate, and then you have pasta. Okay, very good. Now, how does the loop work? Okay, do until end of list. Alright, so we are not at the end of list. Okay, so we need to go select the first unconsidered person on the list as the current person. Okay, we select this fella. Alright, set counter to 0. So let me just put here, my counter now is 0. Okay, output the first letter of the current person's name. So my output will be A, right? Then now we go into the inner loop. Do until counter equals to favorite number of current person. So Alexandra's favorite number is 2. Right now my counter is 0. Is 0 equals to 2? No, right? So the condition to stop hasn't happened yet. So we will run the stuff inside the loop. Output the first 4 letters of the person's current favorite food. So pizza will be first 4 letters will be P's. Okay, then increase the counter by 1. So now my counter from 0 becomes 1. Is 1 equals to 2? No, right? So don't stop, keep going. I will put the first 4 letters of the word pizza, which is P's again, right? And then increase the counter by 1. So now my counter is from 1 is now 2. Is 2 equals to 2? It is, right? So therefore, I will end the loop. Okay? And then I will mark this fella as considered. Then end loop. Now we go back to the top of our do until end of list. And then are we at the end of the list? Not yet, right? So select the first unconsidered person, which is person B, right? And then you go on, so on and so forth. I don't need to run the rest for you to see where this is going, right? So that is how you get the answer. Okay, and now we arrive at the very, very last question. Okay, and unfortunately, well, fortunately for you, we will have, I'm going to moderate this question, and so as long as you did the question, you get 3 marks. Nice, right? Now, why am I moderating this? Because every attempt at phrasing for clarity results in students understanding part 3 of the question the opposite way. So there's no winning this lah. With MCQ, it's very hard to get everybody to interpret it the same way. So I don't want to penalize anyone for interpreting it wrong. But let me just explain how the question is supposed to be answered. Alright. So we have the you work for the Office of Health and Safety in the National University of Sang Nila Utama. Okay, and there's an outbreak of the deadly Hachiu virus. Okay, and while the virus hasn't come to the university, you have started studying the social network of students to better understand how to effectively quarantine them. Alright, so here we have a graph of of this network of students. Okay, A, B, C, and then you have D, then we have E, and then we have F, and then we have G, H, and I. Okay. Question 1A is, which student has the highest degree centrality score? Well, clearly it is this fella, right? Because he has 1, 2, 3, 4, right? Okay. Then question 2 is, part 2 is, which student has the highest Betweenness centrality score? This one, you don't need to do the counting. You can see very clearly that it's this person, right? Because this person is a bridge between people here and people here. You take this person out, so many people will get affected. Of course, okay lah. Part 2B does ask for the Betweenness centrality score. So how do we calculate the Betweenness centrality score? Okay, first of all, we need to pretend that D is taken out of the network, and then we need to count the number of disrupted pairs. Okay, so I won't go through the whole process. You have to do it yourself. Okay, so how does it work? A to B is not disrupted, right? A to C is not disrupted, right? A to E on the other hand is disrupted because it has to go through D to get to E, so we count this as 1, right? And A to G again has to go through D, so we count another one, then and so on basically, alright? Now, okay, next question. So you can work it out for yourself. Don't double count. Okay, don't double count. Okay. Now, part 3A is asking, if someone is infected in the network, which student will be instrumental in facilitating the spread across the entire network? Essentially, who has the highest betweenness, because who will help facilitate spreading from one network to another. Essentially, who is a bridge basically. Yeah. Then 3B is asking, which student, if infected by the Hachu virus, will cause the virus to spread immediately to many people. Then we have person F because person F has the most number of connections. Yeah. Now, some of you are asking, why am I making you calculate all these things manually? What's the whole point of all this? Because when you go out to work, now using circles and lines or nodes and edges, okay, is very, very fashionable. And so many organizations, civil service, private sector, they will use this very, very regularly nowadays. You cannot run away from it. I still remember after I graduated, I sat in for very high level meetings. Boom! People flash these kinds of circles and lines all over the screen, and you are expected to kind of know what's going on, right? Incredibly stressful for me, because when I was in that situation, I had no idea what those circles and lines meant. So I'm teaching this to you so that the next time somebody is going to flash a whole bunch of circles and lines on the screen, whether you're in the civil service or private sector, you don't need to panic. You don't need to be so blur what is going on. You know betweenness centrality, you know degree centrality. You look at all the circles and lines, you say, I kind of know what's going on. I don't know the full story, but I know enough to say something. Yeah. And you do the calculation because then you understand better how they arrive at all these numbers. Okay. Yeah. So this is meant to help you the next time you go out to work, right? But I hope that this is also very interesting. Just by abstracting and modeling data even in a very visual way, we can gain very, very deep insights about networks, about relationships, about friendships. Very fascinating, isn't it? This is just the tip of the iceberg. If you're very interested in social network analysis, please go and learn more on your own. This is just a taster. Okay, I'm done explaining all the quiz questions for lecture quiz 4. So I hope this was helpful. Anything, come and talk to me. I wish you all the best and bye-bye.